Hi everyone, this is Mr. Zhang, and today we'll be going over the math homework for Class P. This is for session U28. For number 1, 247 is a product of two prime numbers. What is the positive difference between these two prime numbers? So what you have to do is to take 247 and see that it's a product, which means you have to multiply. And the key word here is prime. So a prime number has exactly two factors, just one and itself. So what this means is that 247 doesn't really show up in the times table. So you would have to take 247 and divide it by some of the prime numbers. For example, 2, 3, 5, 7, 11, 13. So you know that 247 is not a multiple of 2. And on a multiple of 3, if you add 2 plus 4 plus 7, you get 13, and that's not a multiple of 3. The sum of the digits isn't a multiple of 3. It's on a multiple of 5. You can try to see if it's divisible by 7. And it's not. You can also try 11. And it isn't. And then you can try 13. And 13 times 8 is 104. And 13 times 9 is exactly 117. So the answer is 13 times 9. Third 19 rather. And when you multiply 13 times 19 to double check, you get 247, so everything checks out. So the two numbers are 13 and 19. So in this case, you want to then figure out the difference between the two, which means subtract. So you have to do 19 minus 13, and you get 6. Choice C as the final answer. So here you have to guess and check between 247 and the divisibility rules with the first couple of prime numbers, and eventually you see that 247 is 13 times 19. Then you subtract 19 from 13 from 19. You get choice C. Next, for number 2, even the cast members of the musical Rent know that the number of minutes in the year 2006 is. So here you have to take the number of minutes in a year. So you know that a year is equal to 365 days. In this case, it's not a leap year. And here you have to take 365. You have to multiply by 24 hours a day. So you have to do 365 times 24. And then on the calculator, which would make things a lot easier, to do 365 times 24, you get 8760. And then you know that 1 hour is 60 minutes. So you multiply this by 60, and you get 525,600. That's choice A. Next, for number 3, in the sequence of 7 numbers, the difference between consecutive numbers doubles each time. So each time you keep doubling if you look at the difference between the consecutive numbers. So for example here, from 12 to 18, it's 6. 18 to 30, it's 12. So then between 30 and this number will be 24. So 30 plus 24 would be 54. And 54 to B would be 48. So 54 plus 48 would be 102. Then to go backwards, you know that the difference here can only be 3, so it would be 9. And then the difference here would be 1.5. So 9 minus 1.5 will be equal to 7.5. So what you want to do is 102 divided by 7.5. You get 13.6. Choice D. Next, for number 4, if n is not equal to 0, 8, or -8, how many of these 4 numbers are equal to 5/8? So you have to go through all the choices and see which one is equal to 5/8. Well, if you look at 5n divided by 8n, the n cancels out, and you just get 5/8, which is what you want. And then the other one will be here. If you have 5/n divided by 8/n, here you can do keep, change, flip for this complex fraction. And you have 5/n times the reciprocal, which is n/8. The n's cancel out. This equals to 5/8 as well. So the answer is going to be 2, choice C. If you add or subtract the same number from the numerator or the denominator, it won't always be equal to 5/8. So the first two are going to be wrong. Next, for number 5, if n is the least common multiple of 10 and 18, what's the greatest common factor of 132 and n? So here, the keyword is least common multiple. And to find the LCM, what you have to do is take 10 and 18 and to see if they have any common factors. So there's a 2 and a 5 for 10. And for 18, you have 6 times 3, and a 6 is a 2 and a 3. So both have a common factor of 2. And then what you want to do is those common factors, they'll count just once. And then 5 times 3 times 3 will be equal to 45. So 45 times 2 is 90. The LCM is equal to 90 here. It's the first number that shows up in the 10 and 18 times table. Now what you want to find is the greatest common factor between 132 and 90. So now you want the greatest common factor. That means you want to keep finding factors. For 90, you have 9 and 10. That's 5 and 2. This is 3 and 3. And for 132, you can divide it by 4. And that'll give you 34. And 34 is 17 and 2. And the 4 is another 2 and 2. So if you look at the common factors, you just see 2 and also a let me double check here. So for 132, you can divide this by 4. You get 33, split 34, and 33 is 11 and 3. And 4 is 2 and 2. So for 132, you see a 2 and a 3. Whereas for 90, you also see a 2 and a 3. So the answer here is going to be choice C, 6, when you do the lowest common multiple. The greatest common factor, rather. Next, for number 6, 37 divided by n leaves a remainder of 7. For how many different whole numbers n is this true? So if you have 37 divided by n, that's equal to some number or quotient with the remainder of 7. So that means that the denominator here has to be greater than 7. So it can only be 8, 9, 10, etc. So if you if you subtract 7 from 37, you get 30. So that means that this number, this quotient, has to be a multiple of 30. So a factor of 30, rather. So for 30, you have 1 and 30, 2, 15, and 3 and 10. And then 6 and 5. So if you try to take, you eliminate 6 and 5 because you know that the denominator has to be bigger than 7. And if you take 37 divided by these three numbers, 10, 15, or 30, you'll see that they all will have a remainder of 7. So the answer is choice D, 3. Next, for number 7, determine the positive difference between pi and each of the following 5 estimates of pi. So list your 5 answers from greatest to smallest. The middle number in your list came from which of these 5 estimates? You want to subtract pi from each of these numbers, and really helpful if you have a calculator. For example, some of these, they're all irrational, so you can't really find them by hand. So 22 divided by 7 equal to 3.14285. The cube root of 31 is really 31 raised to the 1/3 power. So you can do 31 and then raise this to the 0.3 power, and that will give you 3.14138. Then you have to square root of 10, which will give you 3.162277, and 355 divided by 113 is 3.1415929. So when you subtract everything from pi, you can list everything in order. So when you take 22 divided by 7 and subtract pi, you get, for the first one, you have 0.0012644. For the second one, you have 31 raised to the 0.3 power. And when you subtract pi, you have negative 0.00021200016. Then for third choice, if you do the square root of 10, subtract pi, you have 0.0206 850066. Next for just 3.14159, subtract pi, you have negative 0.00000026536. And for the last one, 355 divided by 113, and when you subtract pi, you have 0.000002668. So you want to then order these from smallest to biggest. So you want the positive difference, so you can ignore the negative signs. And here, the one with the most zeros in front will be the last one. This is the smallest. Then this has 5 zeros, so this is the second smallest. Then this has 3 zeros, which is the middle. Then this is the fourth, and this is the largest distance. So the answer will be the cube root of 31. The correct answer here is not A, should be choice B. Right, next one, number 8. Cheryl ran a 10-kilometer race in exactly 51 minutes. In nearest tenths, what was her average speed in miles per hour? So you want to find the miles, and to go from kilometers to miles, you know that 1 mile is 1.61 kilometers, and she has 10 kilometers. So here you can do 10 divided by 1.61. And you have to multiply 1 by that number, which will be 6.21118. And now this is in 51 minutes, so you'll have to take 6.21118 miles. And if you divide it by the time, 51 minutes, that's 51 divided by 60. Which is 0.85 hours. So we have 6.21118 divided by 0.85 to find the unit rate. You get about 7.3, which will be choice A. Next for number 9, England and the US always have agreed that 1 million is equal to 1 followed by the 6 zeros. Until recently, the English defined a trillion to be a million billion and a billion to be a million millions. What is the ratio of the former English trillion and the current US trillion? So here a million is equal to 10 to the 6. So it has 6 zeros at the end. Billion is equal to 10 to the 9th, and then trillion is equal to 10 to the 12th. So here, the former English trillion used to be a million billions. So when you have a million times a billion, that's going to be 10 to the 6 times 10 to the 9. And here you can use the law of exponent that states b to the a times b to the c is b to the a times c. So in this case, this will be 10 to the 6 plus 9, or 10 to the 15th power. And when you compare this to the regular trillion, which is 12 zeros, the difference will be choice A, 3 zeros. So there's a difference of 3 zeros between the old English trillion, which is 10 to the 15th, and the current US trillion, which is 10 to the 12th. So here's a summary for this page. Just be careful of the typo for 7 and 8. Next for number 10, you have this complex fraction. And here what you have to do is figure out the innermost fraction, and 1 minus 2/3 is equal to 1/3. So now this piece will become 1 minus 1 divided by 1/3. And now you have to evaluate this by doing keep, change, flip. And that's 1 divided by 1/3, which will be 1 times 3 over 1 when you keep, change, flip. And that will be 3. So this turns to 1 minus 3, or negative 2. And from here, you know that this entire piece will then be negative 2. So what you end up with is 2 plus 1 over negative 2, or 2 plus negative a half, or 2 minus 1/2, which is 1 1/2, or choice E, 3/2. So the key here was to do keep, change, flip. Next for number 11, A and B represent distinct non-zero digits. If the 3-digit number AB7 is 72 larger than the 3-digit number 7AB, what is A plus B? So you have AB7, and if you subtract 7AB, what you get is 72. So here 7 minus B has to be equal to 2, so you know that B might be equal to 5. And then you have 5 minus A is equal to 7, which can't happen unless you borrow. So then the 5 will then turn into a 15, and 15 minus 8 is equal to 7. So maybe 8 is equal to 8. So if you guess jack, here you have 15 minus 8, which is equal to 7. And here this 7 you borrowed minus 7 is 0, so the answer is just 72. So A is equal to 8, and B has to be equal to 5. And if you add them together, you get choice A, 13. Next for number 12, in February 2006, the total U.S. public deficit was estimated to be $8.3 trillion. Suppose that a presidential candidate promised to decrease his deficit at a rate of $1 million an hour. If she's elected twice and keeps her promise for 8 years, what percent of the deficit would be paid off? So in this case, you have the deficit is $8.3 trillion. And here you want to decrease this deficit. So you want to subtract 1 million an hour. So if you multiply by 24, because you know that there's 24 hours in a day, and then you multiply by 365 days in a year, and you multiply this by 8 years, what you end up having is 24 times 365 times 8, which is equal to about 70,080. And this is in millions. So if this is in millions, you want to then compare it to trillions, which is 10 to the 12. And this is 70 million. So if you have 8.3 trillion, that's really, if you move the decimal 3 places, 8,300 billion, and you move it 3 more to add 3 more zeros, that's really 8.3 million millions. And what you decreased was 70,000 of that. So that's your part, and your whole is here. So here, to figure out the part of a whole, you would do 70,080 divided by 8.3 million. And then multiply by 100%. So divide 70,080 by 8.3 million. Then you multiply by 100%. You would get about 8.44 or 0.844%. And that's choice B. Next, for number 13, for how many integers x is the square root of 225 minus x squared a real number? So in this case, if you want this to be a real number, which exists on a number line, you know that the square root, or you have to know that 225 minus x squared has to be greater than 0. If you add x squared to both sides, x squared is equal to 225 if x is equal to 15. So if x is equal to 15, you have the square root of 0, which is a real number. So everything up to 15 or negative 15 would be okay for this. So here you have 0 to 15 and also to negative 15. Well, negative 1 to negative 15, that's 15 numbers. From 1 to 15, that's another 15 numbers. And you want to keep 0 as well. So 15 plus that one number, which is 0, is choice E, 31. So it's all the numbers from negative 15 to positive 15, inclusive. So it includes 0 and includes the endpoints. Next, for number 14, 6 raised to the 10th power times 5 squared is equal to 2 raised to the m times 3 raised to the n times 300. Now, what does m plus n equal? So here you know that 6 to the 10th, the 6 is really 2 times 3. To raise that to the 10th, you distribute the 10. This is one of the laws of exponents. You get 2 to the 10th times 3 to the 10th. And you have 5 squared. So in order to get the 300 on both sides, you know that 300 is really 100 times 3. And this 100 is 2 times 50, and the 50 is 25 times 2, and then there's another 5 and 5. So here 100 is really 2 times 2 times 5 times 5 times 3. So here you can cancel out the 5 squared on both sides, and then you can cancel out 2 of the 2's. So this 2 would just turn into an 8. You have 2 raised to the 8 times 3 raised to the 10th is equal to 2 raised to the m times 3 raised to the n. And here you still have a 3 on the right side, or 2 3's rather. You have the 3 from the, or just 1 3. And then you would cancel out the 3 and turn this into a 9. So you see that m has to be equal to 8 and n has to be equal to 9. So 8 plus 9 is equal to choice B, 17. Here just do prime factorization and then start dividing. Next, for number 15, Beth was earning $8 an hour before a 20% increase in hourly wages. But at the same time, her number of hours worked per week decreased by 30%. Now she's earning $302.40 per week. How much less is this than what she was earning per week before these two changes? So she was earning $8 an hour. and we don't know what her number of hours was, so we can call that x. So her past total was just 8x, if x was however many hours a week. But now, instead of earning $8 an hour, it increased by 20%. So 8 plus 20% of 8 is really 8 plus 1/5 of 8. So if you take 20% of 8, or 8 divided by 5, that's 1.6. Added to 8, that would be a new rate of $9.60. But the number of hours worked decreased by 30%. So instead of X hours a week, you only have 7/10 of X hours a week. So this is your formula that you can use to calculate X. So 9.6 times 7/10 of X is equal to 302.4. Here you can divide by 9.6 on both sides. So we have 302.4 divided by 9.6. You get 31.5. So 7/10 of X is equal to 31.5. From here you can multiply both sides by 10/7, the reciprocal. And you get X is equal to 45. So that one means she works for 45 hours. So this is 45. You would multiply 8 times 45 and you get $360. So she used to earn 360, but now she only earns 302.4. So when you subtract 302.4, you get $57.60, which is choice E. Next for number 16, if x plus 4 squared is equal to 25 and y minus 6 in parentheses squared is equal to 4, what possible value of x plus y is closest to 0? So here you would have to solve for both of these. Since both of these are perfect or squares, you can just do the square root, but you know that x plus 4 could be positive or negative 5. So x plus 4 could be equal to positive 5, or x plus 4 could be equal to negative 5. So x could be equal to 1, or x could be equal to negative 9 when you subtract 4. Again, when you do the square root on both sides, you know that y minus 6 could be equal to 2, or y minus 6 could be equal to negative 2. So y could be equal to 8, or y could be equal to 4. So the difference, the biggest, or the value of x plus y that's closer to 0 would be if y is equal to 8 and x is equal to negative 9, because here 8 minus 9 is negative 1, choice A. Just remember when you do the square root of a number squared, you have the positive or the negative root. Next for number 17, 13 tangent congruent circles are drawn as shown. The centers of the 6 outermost circles lie on a circle. What's the ratio of the area of the large circle to the area of one of the smaller circles? So here you have a whole bunch of these circles. They're tangent and they're all congruent, which means they're all the same size and they're not overlapping each other. So here you want to make sure that you match up the centers with the edge of the large circles. And here you can try to make some geometric shapes so that you find the radius of the large circle, because then you need that to find compared to the radius of the small circle. So here, if you call the small circle's radius r, you know that the edge of this equilateral triangle is 6r. And what you want to find is this radius here. And if you have an equilateral triangle, you can break it up into a lot of smaller shapes. So you can drop the altitude, which breaks it down into two 30, 60, 90 right triangles. But from here, you can also break down one of these into another smaller 30, 60, 90 right triangle. Because here, you know that each of these would be 60 degrees, this would be 90, and this would be 30 degrees. So this smaller triangle here is a 30, 60, 90. So in this case, if the side opposite the 60 is this x, this x would be in ratio of a, 2a, and a root 3. So this x is really this a root 3. And divide by root 3 on both sides. You can figure out that the hypotenuse, which is what you want, is opposite the 90 degrees. And that hypotenuse here is the radius. So that's going to be this piece, which is what you want. Will be 2 times this. So a would be x over root 3. And then the hypotenuse would be 2x over root 3. So that's going to be the radius of the big circle. Will be 2x over root 3. And to find the area of a circle, it's pi r squared. So that's going to be pi times 2x over root 3 squared. And from here, you can distribute this power of 2 to everything inside the parentheses. That will be x times 2 squared, x squared over root 3 squared, which will be pi times 4 times x squared over 3, or 4/3 pi x squared. Whereas for the smaller circle, the radius of r, the area is just pi r squared. So the big circle is 4/3 pi x squared. For the small circle, it's just pi r, or pi x squared in this case. And here you actually have to find the relationship between x and r. Here the x is really this piece, and this piece is equal to 3r. So it'll be pi times this 3r squared. So this would be 4/3 pi times 9r squared. And this is going to be 12 pi r squared. And then for the small circle, just pi r squared. So you divide by pi r squared. Everything cancels out except for 12. So the answer is A. So we have a couple of variables here. You call each piece r. And then this x is really 3r. But the key here is just a 30, 60, 90 right triangle that you can use to match the sides. Another way is to call the radius just 1, and then instead of working with variables, you're just working with actual numbers. And here's a summary for this page. Next, for number 18, Rutherford B. Hayes was elected president of the U.S. in a leap year in the 19th century. The sum of the digits in that year is 22. What's the 10th digit of that year? During the 19th century, it's going to be the 1800s. So remember, leap years occur every 4 years. So because it's an 18, 1 plus 8 is already 9. So 22 minus 9 is equal to 13. So that means the other two digits have to add up to 13. Now you have two digits, A, B plus B adds up to 13, but they put them together. AB has to be a multiple of 4. So you write out the multiples of 4. And to get a multiple of 13, you're going to see that the numbers have to be relatively large. And then you try 52, 56, 60. 64 is 10, which is close to 13. And then 68 is 14, which is not exactly 13. 72. And we'll try 76. You see that is equal to 13. So it must be 1876. So the tens digit has to be choice C, 7. Next, for number 19, if x and y are positive real numbers, which of these three quantities could be the largest? So here, you just want to see which one could be the largest, not must be the largest. So all they have to be are positive. So for example, if you make x and y 1, then, and if they're both 1, then you see that 1 times 1 is just 1, whereas 1 plus 1 is 2, and then 1 divided by 1 is just 1. So in this case, 2 could be the largest. So you can eliminate A and D, because you want to have a choice 2 in there. Then you try another set. If, let's say, x is 4 and y is 5, then 4 times 5 is equal to 20, whereas 4 plus 5 is equal to 9, and 4 divided by 5 is 0.8. So here, A would be the largest, or 1 is the largest, so you eliminate choice C. So 1 could also be the largest as well. Then you want to find another set of numbers in which 3 could be the largest. So remember, they have to be positive real numbers, but they could be decimals. If y is 0.1 and x is 10, for choice 1, it's 10 times 0.1 or 1/10. That's equal to just 1. For 2, that's 10 plus 0.1, that's 10.1. But for choice 3, if you do 10 divided by 0.1, or 10 divided by 1/10, that's really 10 times 10 when you keep change flip, and that's 100. So 3 could also be the largest. So the answer is 1, 2, or 3. So this one you just substitute in and guess and check. Next, for number 20, a rectangle and an equilateral triangle have the same perimeter. The length of the rectangle is twice its width, and the length of each side of the triangle is 30 centimeters. What's the area of the rectangle? To triangle, if it's equilateral, all three sides are equal. It's 30, 30, 30. So the perimeter here will be 90. For the rectangle, though, you know that the length is twice its width. So you have the width, and the length is 2w. So the perimeter here will be 2w plus 2w plus w plus w, or 6w. And this 6w has to be equal to 90. So 6w is equal to 90, and the width has to be 15. So that means that the area of the rectangle will be 15 times 30, and the area here will be 450. Choice B. Next, for number 21, it was reported in February 2006 that the Antarctic ice cap may be losing 250 cubic kilometers of ice per year. The radius of the Earth is about 6,360 kilometers, and 75% of the surface is covered by water. For a sphere, the surface area is equal to 4 pi r squared. If 250 cubic kilometers of water were added uniformly to the water-covered area of the Earth, what is the depth of that layer in millimeters? So here you have, to find the surface area of the Earth that is covered in the ocean. So you have the formula. You have 4 pi, and the radius is 6,360. And this is in kilometers, and you have to square that. But now this is there's only 75% that's covered. So you have to multiply this by 3/4. And once you get this, you'll have to divide by the volume of the volume of the ice that is melting every year. So I have to take 250 divided by this number. Or rather not 250, it's this 250 cubic kilometers they have to divide. All right, so you'll have to do 4 times pi times 6360 squared, and then multiply by 0.75. And then you'll have to do on the calculator, so this would be approximately equal to 381,228,498.60193. You have to take 250 divided by that number. And the answer will be 0.00000006558, and this is in kilometers. To go from kilometers to millimeters, you know that there are actually 1 million millimeters in a kilometer. So you have to move the decimal over 6 times. And the answer will be 0.6558 millimeters, and that's choice B, 0.7 millimeters. Next, for number 22, a triple prime is a set of 3 consecutive odd numbers, all of which are prime. How many sets of triple primes are between 0 and 200? So you have 3 consecutive odd numbers, and they're all prime. So consecutive means next to each other. So you start listing out the prime numbers. You see that 3, 5, 7, these are consecutive odd numbers, and they are all prime. And we keep listing them out. You see that you're not going to get another set, because one of them is going to be a multiple of 3. For example, the 15 is a multiple of 3, belongs here. 21 is a multiple of 3, so that's there. So I meant to say 23 there. 21 is a multiple of 3, that is here. Then you have 25 is a multiple of 5, and 27 is a multiple of 3, that's there. And then 33 is a multiple of 3, that's after 31. So you won't ever have 3 consecutive odd numbers, because one of them will be a multiple of 3. So the only one is just 3, 5, 7, where 3 is a multiple of 3, but 3 is so prime. So it's choice B, there's only one, 3, 5, and 7. Next, for number 23, in this semicircle, the 2 congruent circles with centers A and B are tangent to each other and to the semicircle. Points A and B lie on the radius perpendicular to the radius CD. What is the ratio of the area of the semicircle to the area of one of these smaller circles? So to figure out the area of one of these smaller circles, I can call the radius R, and that means that the radius of the larger semicircle is going to be 4R. So to find the ratio of the semicircle, the area is going to be 1/2 pi r squared. It's going to be 1/2 pi times 4r squared. To apply this exponent of 2 to the 4 and the r, that's going to be 1/2 pi times 16r squared. And that will be 8 pi r squared. And then for one of these smaller circles, the area is just pi r squared. So if you divide 8 r squared 8 pi r squared, divided by just pi r squared. Everything cancels out except for this 8, so the answer is choice C. Next one, number 24. ABCD is the square with AB equal to 10 centimeters, and CDE is an equilateral triangle. Segment FG is parallel to AB and splits pentagon ABCED into two regions of 2 equal area. To the nearest millimeter, what's the length of BG? So here we have ABCD, which is a square, and each side is equal to 10. And then CDE is an equilateral triangle. So because each side is equal, it matches with the square, so each side is also equal to 10. Now FG is going to be parallel to AB, and it splits this pentagon into two regions of equal area. So I want to figure out what is the length of BG. So let's find the total area. And the total area is a square plus the triangle. So the square is easy because that's just side squared, or 10 squared, which is 100. For the equilateral triangle though, you have to find the height. And the height will split this equilateral triangle into 30, 60, 90. So you have 5, 5, and 5 root 3. It's x 2x and x root 3 for this 30, 60, 90 right triangle. So the area is going to be 1/2 base times height, or 1/2 10 times 5 root 3. And here that would be 25 root 3. So to add that to 100, 100 plus 25 root 3. Now you want to get an estimate for that. And that will be equal to 143.3012. So you take this area and divide it by 2. So you want 71.6506. And this will be the area of this rectangle here. And for this rectangle, you know, the base is 10. So the height has to be 7 point, for BG, it has to be about 7.165, or choice D, 7.2 when you round. The key here was this 30, 60, 90 right triangle. To find the total area of the square and the triangle, then you divide it by 2, and then you divide it from the rectangle on the bottom. So here's the summary for this page. Next, for number 1, which of the following numbers is divisible by 3? So divisibility by 3, just add the digits. So 2 plus 9 is equal to 11. That's not divisible by 3. Here, this is 11, which is not divisible by 3. 200 minus 9 is 191. And here, 1 plus 9 plus 1 is equal to 11, which is not divisible by 3. 2 raised to 9 doesn't have any 3's in there, so that's not right. Whereas for E, you have 2 plus 0, which is 2, times 0 plus 9, which is 9. That's 18. 18 is a multiple of 3. So the answer is E. Next one, number 2. What's the minimum number of points which have to be removed from the adjacent diagram so that the remaining picture has no 3 points lying on the same line? So if you remove the 3 in the diagonal, you can't make a line with 3 points anymore. So the answer is choice C. You can't remove just 2. You must have 1 point in each row and 1 point in each column. Next one, number 3. 2009 people are taking part in a public fun run. The number of people Hans beat is 3 times as big as the number of people that have finished before him. In which place did Hans finish the race? So we don't know where Hans is, but there are some people that are in front of him, and there's some people that are behind him. So the people that are behind him, the people that he beat, are 3 times as big as the number of people that finished before him. To beat, if there are X people in front, there will be 3X behind him. So you have 3X plus X plus 1 plus Han will be 2009. So that means that 4X plus 1 is 2009. So 4X is 2008, which means that X has to be 5 102. So if X is 502, Hans was in 503rd place. Choice A. Next, for number 4, Harry does his paper run in Longstreet. He has to deliver one newspaper to each house with an odd number. The first house with an odd number is 15, and the final house has the number 53. How many houses does Harry have to visit? So he only does the odd numbers, and you know that 53 from 15. Here it helps if you have the even numbers to help you figure out the multiples. So 14 is 7 times 2. So 15 is the number after that. And then 52 is 26 times 2. And 53 is the number right after that. So to go from the 15th to the 53rd, here you can either count forward or you can just subtract. But if you count forward, 15, 17, 19, 21, 23, then you have 25, 35, 45, and you don't have the 55, because when you have 45, 47, 49, 51, and 53, you make exactly a grid of 4 by 5. So there are exactly, choice B, 20 numbers. Now just be careful when you subtract and divide by 2, because you have to add one of the endpoints. 53 subtracted by 15 is 38, and if you divide by 2, that's equal to 19. But you have to add 1 for the endpoint, so that would be 20. Next, for number 5, the product of 4 different natural numbers is 100. What is the sum of the 4 numbers? So you need 4 different numbers, and natural numbers are the counting numbers. They multiply to 100, so they're all factors. So you know that 100 broken down to 50 and 2. This is 5 and 10. This is 5 and 2. So you can't have 5 times 5 times 2 times 2 because it has to be different numbers. So if you want to have 4 totally different numbers, you can have 25 times 4, or rather 2 times 10 times 5, and then that's already equal to 100, and you have to also multiply by 1. So if you add everything together, 1 plus 2 plus 5 plus 10 would be equal to choice D, 18. Next, for number 6, what's the value of 1/2 times 2/3 times 3/4 times 4/5, etc.? Here you can see that it's a telescoping series because the numerator cancels out with the denominator, and then the 10 will cancel out one of the zeros, so you just have 100 left over, choice C. Next, for number 7, a long number is built by writing the number 2009 times in a line. How big is the sum of all the odd numbers within this number that are immediately to the left of an even number? So here you have to make a really big number, etc. And you want to figure out the sum of all the odd numbers within this number that are to the left of an even number. So here in this case, it will be the 9s, because there's only a 9 that's to the left of an even number. So you'll have to do 2009 times 9, because there are 2009 nines. And 2009 times 9 is 18,081. However, the last 9 won't be to the left of the even number, so you have to subtract 9 from that. And you get 18,072, choice D, and not choice E. The last digit doesn't count because it's not to the left of an even number, so you can't include that. Next, for number 8, the diagram on the right shows a solid made of 6 triangles, and each vertex is assigned a number, 2 of which are indicated. The total of the 3 numbers on each triangle is the same. What is the total of all 5 numbers? So here you don't know what the last number is, So you can call it x. For example, for this triangle, that's 1 plus 5 plus x. And that has to be the same for, if you make this one x, same as x plus 1. So here you can subtract x on both sides. You get that 6 is equal to x plus 1, which means that x has to be equal to 5. And that means that the bottom has to be a 1. So to figure out the sum of all 5 numbers, it's 5 plus 5 plus 5 plus 1 for the top and bottom. That's choice C, 17. Next for number 9, for how many positive whole numbers a do a squared and a cubed have the same amount of digits? So here just want to make a table of a squared and a cubed. So a could, you just want positive whole numbers. So a is 1, 1 squared is 1, 1 cubed is 1. So that's one of them. But if a is equal to 2, 2 squared is 4, 2 cubed is 8. So yes, they also have the same number of digits. But if you try 3, 3 squared is 9, 3 cubed is 27. So that doesn't work. And try 4, 4 squared is 16, 4 cubed is 64. So they both have 2 digits. And try 5, and you get 25 and 125. So they get larger and larger. So it sees that the cubic functions just increase exponentially. So there won't be a time where the cubic function will have the same number of digits as the square function. When you want to go to the 3 digits, you have to do 10 squared, which is 100, but then 10 cubed is already 1,000. So that's now 4 digits. So it'll never catch up. So the answer is choice B, 3. Just 1, 2, and 4. And here's a summary for this page. Next, for number 10, the area of the shown triangle equals 80 square meters. Each circle has a radius of 2 meters, and its center is one of the vertices of the triangle. What's the area of the gray shaded region in square meters? So you can't really see the gray region here, but you have to kind of assume that it is within here. So if you want to find this region, the area is equal to 80, and each of the circles has a radius of 2. And the key here is to figure out that these 3 angles add up to 180 degrees. So if you put these sections together, that will be 180 degrees of this circle, which is half of the circle because the whole circle is 360. So the area is pi r squared, but you only want the semicircle. So the semicircle area will just be 1/2 pi r squared. And in this case, r is equal to 2. So that'll be 1/2 pi times 2 squared, or 1/2 of 4 pi, which is equal to just 2 pi. You want to subtract 80 minus 2 pi. And that will give you the area of the piece that should be shaded gray. So that would be that area. Next, for number 11, Leonard made up a sequence where, starting with the 3rd term, each term is the sum of the previous 2 numbers. The 4th number is 6, and the 6th number is 15. What's the 7th number in the sequence? So you make a couple of terms. Here you know that the 4th number is 6, and the 6th number is 15. So here you know that 6 plus 9 is 15. And then you know that 3 plus 6 is 9. And then here you can figure out that this is 3, and the first number has to be 0. And then 15 plus 9 would be 24. So the answer is choice E. Now just follow the pattern. Next, for number 12, in the triangle illustrated, one internal angle measures 68 degrees, and the 3 angle bisectors of the triangle are shown. What is the size of the angle indicated with a question mark? An angle bisector, it cuts the angle in half. So this 68, for example, turns into two 34s. And then the other angles also get cut in half. And we don't know what they are, so we can call one of them x, the other one can call y. You know that x plus y plus 68 has to be equal to 180, because that's the whole triangle. So if you try 180 minus 68, you get 112, and that's equal to 2x plus 2y, which means that x plus y has to be equal to 112 divided by 2, or 56. It means that this angle here has to be 180 minus x minus y, or 180 minus x plus y, which is equal to 180 minus 56, or 124. So choice B. You actually don't know what x and y are. It doesn't actually matter, but that angle has to be 124. Next one, number 13. Maria can achieve 0, 1, 2, 3, 4, or 5 points in a test, and after 4 tests, she has a mean or an average of exactly 4. One of the following sentences can therefore not be true. Which one is it? So just go through all the choices and see one, and try to make it true, and you can eliminate that choice. So here, after 4 tests, her average is 4. So remember, average or mean is the total divided by the number of data. So that means that 4 is equal to the total divided by 4. So the total has to be 4 times 4, or 16. So if the total is 16, you can go through all the choice here. Maria can achieve a 4 in each test. That is true. 4, 4, 4, 4, which is a total of 16. For choice B, Maria achieved a 3 exactly twice. You can have 3 and 3, which makes up 6. And the last two could be 5 and 5. So that could work. So B is wrong. For C, Maria achieved 4 exactly twice. You can have 4 and 4. And the last two has to add up to 8. So you can have 5 and 3. So that's fine. And for choice D, Maria achieved 1 exactly once. You can have a 1, which means the last two has to be 15. And you can have that. You can have 5, 5, 5, because 1 plus 5 plus 5 plus 5 is 16. Which means the answer has to be choice C based off the process of elimination. You can't actually have 3 exactly 3 times, because that's equal to 9. So 16, which is the total, minus 9 is 7. Or, 16 minus this 9 is 7, and you can't have a score of 7. The most you can have is a 5. So the answer has to be choice E. Next to number 14, the Borromaic rings have an extraordinary property. Although no two are interlocked, they are strongly connected within each other. If one ring is cut through, then the other two fall apart. Which of the following diagram shows the picture of the Borromaic rings? So here you want to see if you cut one of the rings, the other two will fall apart. So if you just go through this and guess and check, if you cut the top ring, for example, I don't know if this is on top, the last two are still together because you have this circle on top, and then this one, the left, the one on the right on top, so they're still interlinked. If you cut this circle here, then the last two, you have the last two circles on the side. You have this one's on top, and then the other one's on top over here, so it doesn't help. They're still interlocked, and if you cut this ring, you see that the bottom left circle's on top here, but then the top left circle's on top here, so that doesn't work. Then you go to choice B. If you cut the top ring, and you see that the left ring's on top for both, so that means that this will actually fall apart because the left ring is on top for both of these intersections, this ring will now be in front, and then this last one will be in the back. So the answer is choice B. Next to number 15, on an island of nobles and liars, 25 people are standing, I guess, in a queue. The first person in the line claims that everyone behind him is a liar, and each of the other people claim that the person in front of them is a liar. How many liars are actually in the queue? So nobles always tell the truth, and liars are always lying. So here you have 25 people that are standing in line, and you don't know who's telling the truth or who's lying, so you have to assume either scenario. So scenario 1, the first person could be a noble. If the first person's a noble, that means it's a truth teller. And the first person saying that everyone behind him is a liar. So if this person's telling the truth, then everyone behind him is a liar. So let's see if that's valid. The second person is a liar, and the second person is saying that the person in front of him is a liar. And that's false, because this person's telling the truth. It's a noble. So the first person can't be a noble, can't be a truth teller. So then we know that the first person has to be a liar. So not everyone behind the first person is a liar. Some of them are telling the truth. All right, so if the first person is a liar, then you can go to the next person. So the second person will say that, oh, the person in front of them is a liar. Well, that has to be true. The first person is a liar, so the second person will be telling the truth. And then the next person, you'll do the same thing. Here, the next person will have to lie because the person's telling the truth. So you can't say that he's telling the truth. You have to say that a person in front of him is a liar. And then you have this pattern. So it'll be LT, LT, LT. So in this case, because you have 25 people, the last person will also be a liar. So there'll be 13 liars and 12 truth tellers. So the answer will be 13 for the number of liars in this line. It'll be LT, LT, LT. You just have to go through these scenarios and go through the statements. And here's a summary for this last page. All right, thank you everyone for joining me today. Enjoy the rest of the day, and I'll see you guys next time. All right, bye everyone.